This is 1-8 in the workbook, solving equations by adding or subtracting. So let's take a look. As you can see, we're going to start off with question number 2, and you're going to do 1, 3, and 4 the same way. The directions ask us to determine which value of x is a solution for the equation. So what you're going to do is you're going to take and plug each one of these numbers in for x here. And one of them is going to cause the left side to equal the right side. And whichever one causes that to happen is a solution to the equation. So if I change x into 6, it would be 9 plus 6 over here, which is 15. But notice the other side says 17. So that did not cause the left side to equal out to the same as the right side. So it is not the solution. Then we'll try 8. 9 plus 8 over here. Well, 9 plus 8 is 17, and the other side says 17. So since that caused the two sides to equal out, that is a solution to the equation. Now, most of the equations we're dealing with today only have one solution, but not all equations that you will encounter over the course of your mathematics career have only one solution. So I will check the other one. I know it's not going to work, but when I do 9 plus 26, that's 35. The other side says 17. It's not the solution. So the value of x that is the solution is 8. Now down in the bottom part there, we're going to take a look at 5 and 6, where we're actually going to formally solve an equation. We're solving the equation by adding or subtracting here, as the case may be. So we're going to show our work here. The work here for a one-step equation, which is what these are in 5 and 6, is not a big deal. Remember, we talked about a few different things here today in class, and over time we have as well, about solving equation. Remember, we want to keep our variables on the left side of the equal sign. And as you can see in both of these, the variables are on the left side of the equal sign. Our numbers, our constants, whatever you want to refer to them as, those are basically going to end up, when it's all said and done, on the right side of the equal sign. One of the other rules is that you're allowed to flip the sides if you need to make that happen. We don't need to do that in either of these questions, but you could end up doing it today. And the reason I say I don't need to do it in either of these is because the variable in 5 is to the left of the equal sign. The variable in 6 is to the left of the equal sign, and that's what we said the rule was. Variables to the left of the equal sign. And the other rule that would be most important here and how to actually solve is opposite side, do the opposite. And when I say opposite side, do the opposite, what I'm talking about is when you are trying to get all these things in the proper location, variables on the left, numbers on the right, your constants, whenever you have to move something to the other side of the equal sign to make that happen, you do the opposite operation. That is to say, for instance, if there was a subtraction sign in front of it originally, when I move it, I'm going to add it. Again, think of it like balancing a scale. If I add 9 blocks to the other one side of a double beam balanced scale, the only way to keep it balanced, if it was balanced to begin with, is to add 9 to the other side. Otherwise, the scale is no longer in balance, and that's really what solving an equation is. So as we look at number 5 here, we see that we've got this 8, that's a number, and that's on the left side of the equal sign, but it belongs on the right side of the equal sign. So I'm going to move that, and again, I'm going to do that by doing the opposite. Well, it's got a big old subtraction sign in front of it, so the opposite is to add. I'm going to add 8 to both sides. And notice when I'm saying both sides, I mean to the left side of the equal sign and the right side of the equal sign. That's always the separator when we're talking about sides. All right, now over here, minus 8 plus 8, those are going to wash each other out. So I'm going to scratch those out. Think about it. If it said 3 minus 3, what happens to 3 minus 3? It goes to 0. Same thing here. Negative 8 plus 8 goes to 0. Just leaves me n, which is great because now that's the only thing on the left side of the equal sign. And then over here, I've got 11 plus 8, which is 19. And we can check that to make sure we did this right. Change n back into 19. What is 19 minus 8? Well, 19 minus 8 is 11. Notice the other side of the equal sign says 11. So since it worked out, we know we did this correctly. When we're taking a look at number 6, more of the same here. Now what's a little bit different about 6 is that the variable g is actually the second thing. But it only has to be on the left side of the equal sign. It doesn't actually have to be the very first thing we see here. So now I'm going to look at shoving all my numbers over to the right side of the equal sign, which means the 9 has got to travel here. And remember, we're going to do that by doing the opposite. Now, problem, there's no sign in front of 9 because it's the first thing. There's no addition sign there, there's no subtraction sign there, there never would be. So think of opposite then in terms of signage of the numbers. 9 right there is a positive number. What's the opposite of a positive? Well, the opposite of a positive is a negative. What do we know about a negative? Well, a negative sign looks like a subtraction sign. Bingo. You're going to subtract 9 from both sides. Again, when I say both sides, I mean both sides of the equal sign. Notice what happens here. 9 minus 9. That goes to 0. It's gone. Right? That leaves me g, and it leaves me 13 minus 9, which is 4. And as you can see, when I plug that in for g there, I've got 9 plus 4, which is 13.